So hi everyone, welcome to Raaonline. This is Dr. Srivatsan, your faculty for biochemistry. Okay, so in today's session we will be seeing about the part 3 of your protein synthesis, that is the translation in eukaryotes. In the previous session we have seen about the translation in prokaryotes. The prokaryotic translation is much simpler, whereas the eukaryotic translation has got much more complex processes involved in it. Okay, so this forms a primary difference of the translation in prokaryotes as well as in and eukaryotes. Okay, and like the previous part 2, I will try to discuss the various kinds of inhibitors of translation in eukaryotes along with the session itself. Clear? Now it is similar to that of the prokaryotic translation, but before that, what is the role of mRNA here? What is the fate of mRNA which has been formed in eukaryotes? In prokaryotes, the mRNA formed will remain it will be remaining blank after splicing. Okay, but in this case, the mRNA in case of eukaryotes will undergo various kinds of post transcriptional modifications. What are those post transcriptional modifications? For attachment of a 5' 7-methyl guanylyl cap. So this is the cap which has got attached at the 5' position. Then we have got a multiple number of A adenine addition of polyase to the 3' region. Okay, so what is the function of these two? The 5' cap is going to protect this mRNA from the activity of 5' exonucleases. The polyase on the 3' region, what it does, it actually increases the length multiple times, so that it actually effectively prevents this translating part from getting affected, from getting degraded by 3' exonucleases. Okay. Now what is the first step which occur during the translation of mRNA in eukaryotes? The first thing will be your activation of tRNA. How do you activate your tRNA? You need to activate your amino acids first. The activated amino acid is the one which has got attached with that of the amino acid tRNA, and this the amino acid enzyme, and this amino acid enzyme will be recognized by dihydrouridine arm of the tRNA, and with the help of that it recognizes that amino acid according to the anticodon which is present in it, and to this amino acid comes and attaches there to that tRNA. So these tRNAs are called as charged tRNAs. That will be your first step. After that, you have activated your tRNA. Just imagine it has some kind of a function which is happening in a huge hall, and in that function some 2 delegates are coming. One delegate is from the gene side and one delegate is from the protein side. Okay, and it requires some kind of an intermediate adapter for the translation to happen. Everything is happening inside that hall on a big stage. This is effectively your translation. Now that you have prepared your adapters, you have prepared your translators. Okay, now you have to activate your mRNA. How are you going to activate your mRNA? In case of prokaryotes, the mRNA directly comes inside the ribosomes, whereas in case of eukaryotes, it needs to be activated first, it needs to be primed first. So how it is being done? It is done by the first checkpoint, which is 4F, factor 4F. Okay, so this factor 4F has got 3 subunits in it. Okay, it has got subunit 4G, 4A and 4E. F-gay, you can remember it like that, F-gay. Okay, 4F has got 3 subunits in it, 4G, 4A and 4E. The 4G is the one which effectively is 4F. I mean it goes, it attaches to the cap region. The function of this 4F is to go and attach to the cap region. Okay, so effectively that attachment with the cap region is being carried out by your 4G. So 4G is the one which is originally getting attached to that 5 prime 7 methyl guanylyl cap region. Okay. So what is the role of 4A, factor 4A? Factor 4A actually removes the secondary structures which have been formed in the mRNA, because it's a very long mRNA, right? It has some, it is prone to get twisted into some formation of new secondary structures. These secondary structures will be removed and the mRNA will be stretched, ironed. Okay. So what is the role of 4E? If something is going to attach at the cap position, it needs to know where the cap is. So 4E actually does this function. It actually recognizes the cap. Once it recognizes the cap, the 4G goes and binds there, and 4A is simultaneously ironing the entire mRNA from the secondary structures. So this is the first checkpoint, okay, from which the translation is being controlled. Once this